Welcome YouTubers to another episode in my Grammar Hero series. In this video I'm going to be discussing distance problems, that is D equal RT problems, which have a very high likelihood of appearing on the Asvab. Before I do that, I just want to take a few minutes to discuss the Asvab itself. In short, the Asvab is a computer adaptive test that's composed of 10 different subtests. And as you can see here, those subtests are general science, arithmetic, reasoning, word knowledge, and so on. You receive a score for each subtest, and in addition to receiving a score for each subtest, you're also going to receive what's called an Afqt score. Afqt, of course, stands for Armed Forces Qualification Test. That's the score that says that you're either qualified to join the military or not qualified to join the military. More specifically, the Afqt score is determined by 4 scores, or 4 subtests. It's determined by your arithmetic reasoning subtest, your word knowledge subtest, your math knowledge subtest, and your paragraph comprehension subtest. In other words, these 4 subtests are put in a formula and you're given a percentile rank based on how well you did on these sections. And if you take a look over here, you can see that in addition to having a percentile rank, you will also be grouped into a different recruit category. Ideally, you want to score in category 3B or above. So for example, if you scored a 65, you would be considered a category 2 recruit, and your score of 65 would indicate that you perform better than 65% of all test takers on this exam. Similarly, if you scored a 31, you would be a category 3 Bravo recruit, which means you scored better than 30% of all, or 31% of all test takers. So that's all I wanted to say about the Asvab itself. You can see here that of all the sections on the Asvab, you're given the longest amount of time to do the arithmetic reasoning section. Again, since you're not allowed to use a calculator on the Asvab, you're going to have to work out all of these problems by hand, including by doing long division with decimals and fractions. So that's why it's so long. With regard to distance problems, I just want to finally say that they come in 2 different flavors. The first flavor is this. You have 2 objects heading toward each other. You'll be asked to calculate when they'll meet. And similarly, the second type of problem will be 2 objects heading away from each other, and you'll be asked to calculate how far apart they are after a certain distance. So all that said, let's go ahead and get started with my presentation. My first question is this. If you traveled at a rate of 60 miles per hour, how many miles would you have traveled after 30 minutes, 45 minutes, 1 hour, 1.5 hours? Okay. The reason I start with this problem is because when you're working on distance problems, you have to make sure that if you're working with miles per hour, you're working with hours. Okay, so if you take a look here, this is 1 hour, this is 1.5 hours. We can work with these. As far as these first 2 go, though, 30 minutes and 45 minutes, again, we're working with miles per hour. These are minutes. We're going to have to do something, as you'll see shortly, to make these scenarios work. So that said, I'm going to work number 3 first, and as soon as I do that, I'm going to jump back to number 1. That way you can see what I'm talking about. So again, we're working with the distance formula, which is represented by D equals RT. D, of course, stands for distance, R stands for rate, and time stands for time, or T stands for time. Typically, distance is in miles, rates in miles per hour, and times in hours. Okay? What you do is, given the information you're provided, you go ahead and plug things into this formula and use some basic algebra skills to solve accordingly. So, in this case, we're We don't know what our distance is. That's what we're trying to find out. We know our rate is 60 miles per hour, and we know our time is 1 hour. Okay, so this problem becomes 60 times 1, which is just 60. So you know that after an hour, if you're traveling 60 miles per hour, you'll have gone 60 miles. Pretty straightforward, and again, I'm purposefully making this problem easy. That way when we get to more difficult problems later in the presentation, you'll have this tool to use. Okay, so let's go to number 1. Again, we're working with the distance formula, d equals RT. We're plugging things in. We don't know how far we're going, so we're going to leave distance blank. We know we're going at a rate again of 60 miles per hour. We know our time's 30 minutes. Okay, the wrong way to do this one would to take 30 and plug it in for your time. Again, at the beginning of this question, I said if you're working in miles per hour, you cannot plug minutes into this formula. You have to make it proportional to hours. So whenever you're given something in minutes and the question's in miles per hour, you have to convert it. So in this case, what we're going to do is put 30 over 60, because there's 60 minutes an hour, and we're going to work out the problem as normal now. So typically you want to convert these fractions to decimals, which will make the math easier. So this would be 60 times 30 over 60 is 1/2, which we can represent as 0.5. Okay, now we'll just work out 60 times 0.5, and I'll do that off to the side here. When you multiply whole numbers by decimals, you make the decimal whole number by moving the decimal over, and you count how many spaces you moved it over. In this case, I moved it over 1 to the right. At the end of this problem, I'm going to move it back to the left. So 5 times 0 is 0. 5 times 6 is 30. Throw our 1 decimal back in from the right, so we get 30. We know the distance here is 30 miles. Okay. Let's try 45 minutes. Again, we're working with distance equals rate times time. We don't know our distance, but we know our rate is 60 miles per hour. We know our time is 45. If you did this, you would get it wrong. So you have to convert it to make it out of hours. 60 times 45 over 60. Okay. And as I did over here, I'm going to convert this to a fraction. 45 over 60, it turns out, is 3/4, or 0.75. I'll go ahead and work this out. Again, move your decimal place twice. Add it back in at the end. 5 times 0 is 0. 5 times 6 is 30. Bring down a 0 since we're starting the second integer. 7 times 0 is 0. 7 times 6 is 42. Add 0 plus 0 is 0. 0 plus 0 is 0. 5 plus 3 is, or 3 plus 2 is 5, and 4 plus 0 is 4. Add your 2 decimals back in. This gives you a distance of 45 miles. Okay? And because I use 60 miles per hour, the math's turning out to be pretty easy in this case. As you'll see in the next problem, when you change up the miles per hour, this math doesn't always work out this nicely. So this last example, again, we're working with the distance formula, trying to find out how far or the distance we traveled after a certain amount of time. We know our speed is 60, our rate is 60. We know our time's an hour and a half. Take a look. This one's already in decimal form for us, so we don't have to do anything in terms of fractions. This is simply going to be 60 times 1.5. Again, we want to make that decimal into whole number, so we're going to move the decimal place once. We'll add that back in at the end. 5 times 0 is 0. 5 times 6 is 30. Add a 0 since we're starting a new line. 1 times 0 is 0. 1 times 6 is 6. add 0 plus 0 is 0, 0 plus 0 is 0, 3 plus 6 is 9, add our decimal back in. Distance in this case is 90 miles. Okay? Few key takeaways. Again, if it's in minutes and you're working with miles per hour, you need to convert minutes to hours. If it's already in hours form with decimals, that's okay. You can still work that out as normal. Okay? So, question 1. If you're in a car traveling 50 miles per hour, how far will you travel in 45 minutes? Again, for every problem in this presentation, we're going to be working with the distance formula. We don't know how far we're traveling. We know the rate at which we're traveling is 50 miles per hour. And we know the time is 45 minutes. Again, we can't throw 45 minutes in there since we're working with miles per hour. We need to put 45 over 60, which, as we saw in the previous slide, our slide is 0.75. Now we can work this out. 50 times 0.75. Bring your decimal over 2. At the end, we'll add it back in. 5 times 0 is 0. 5 times 5 is 25. Bring down a 0 since we're starting a new integer. 7 times 0 is 0. 7 times 5 is 35. Let's add. 0 plus 0 is 0. 0 plus 5 is 5. 2 plus 5 is 7. 3 plus 0 is 3. Bring in our two decimals that we took away. We can see the distance in this case is going to be 37.5 miles, which is C. Okay? Now, if you didn't see that previous slide, you might have just thrown 45 in there and you would have gotten it wrong. Train A is heading west and train B is heading east at 4 p.m. They are 260 miles apart. If train A is traveling at 70 miles per hour and train B is traveling at 60 miles per hour, what time will they meet? Okay, so they're heading in the same, they're heading toward each other. Train A is heading this way. Train B is heading the same toward train A. We know train B is heading at traveling at 60, whereas train A is traveling at 70. We know they're traveling a total distance of 260 miles. Question is, how long will it take them to meet in the middle somewhere? So one way to think about these problems is to think about the distance the trains are traveling and their speeds. Regardless of their speeds, both trains are going to travel a total distance of 260 miles per hour together. Okay? So when I think about these problems where they're traveling toward each other, a defined rate but different speeds, I always think about train C traveling 260 miles, the same distance as A and B, albeit at a combined rate of these two trains, that is 130 miles per hour. This problem right here is identical to this problem. This problem requires more work. This problem's much simpler. Again, train C traveling 260 miles at 130 miles an hour is the same as two trains traveling 260 miles, albeit at different rates. So let's go ahead and use the fact that these are the same problems and set up our problem accordingly. So distance equals rate times time. We know we're going 260 miles. We know the trains are traveling at a combined rate of 130 miles. We want to figure out when they're going to meet. So we're interested in the time it takes them to travel 260 miles. Divide both sides by 130 to get t by itself. This crosses out. We're left with t equals 260 over 130. You can cross out the zeros to make the problem a little easier. You're left with t equals 26 over 13. And of course, 26 divided by 13 is 2. So in other words, it will take these two trains at their differing rates 2 hours to cover 260 miles. They left at 4. 4 plus 2 hours is 6. Okay? Again, think about these problems as combined rates. The math is identical. A car headed west for north plot left at the same time a car heading east left at the same place. The car heading west traveled at 55 miles per hour. Car heading east traveled at 70 miles per hour. How many miles apart were the two cars at the end of 2.5 hours? So in this case, we have two cars starting at the same place. One's heading this way. One's heading this way. The question is, after 2.5 hours, how far apart would they be? This one's traveling at 55 miles per hour. This one's traveling at 70 miles per hour. As was the case in the last problem, imagine if you had car C here traveling one distance, the same amount of time, albeit at a combined rate of 70 plus 55 miles per hour. So imagine if you had car C traveling 125 miles per hour for the same amount of time. Again, this is the same problem. The math just turns out to be easier. So using this fact down here, we're going to plug these numbers into our distance formula and figure out the answer. So distance, that's what we're after. We know they travel 125 miles an hour, or a combined rate of 125 miles an hour for 2.5 hours. Okay, let's go ahead and work that out. Since we have a fraction here, we're going to move it over one spot and add it back in at the end. 5 times 5 is 25, carry the 2. 5 times 2 is 10, add 2, that's 12. Carry the 1. 5 times 1 is 5, plus 1 is 6. Bring down a 0 since we're starting a new row. 5 times 2 is 10, carry the 1. 2 times 2 is 4, add 1, that's 5. 2 times 1 is just 2. 5 plus 0 is 5. 2 plus 0 is 2. 6 plus 5 is 11. Carry the 1. 2 plus 1 is 3. Add our 1 decimal place back in. So after 2.5 hours and traveling a combined rate of 125 miles per hour, they're 312.5 miles apart. Okay? Now the other way to have done this one would be to do D equals 2.5 times 55, or D equals 2.5 times 70. Get these two distances and add them together. This way is much more efficient. You're less likely to make a mistake, and it shows that you understand the principle of distance over rate times time. Okay? Train A headed north at 65 miles per hour. Train B is also heading north on adjacent tracks at 72 miles per hour. At the end of 4 hours, how much farther will train B have traveled than train A? So let's just pretend they're heading east instead of north. We got one train heading this way, the other one's heading the same way. Let's just call this one A, this one B. Train A is going 65 miles per hour. Train B is heading 72 miles per hour. And the question is, how much further will train B be after the end of 4 hours of commuting? Now, since we're interested in the distance traveled between these two, we can't combine the rates. So we're going to have to do two separate problems. That is, we're going to have to do distance equals rate times time twice. Okay, So let's call this one train A, train B. We know we're after the distance both travel, so we're going to leave that as D. We're told that train A is traveling 65 miles per hour at a rate of 4 hours for a total of 4 hours. We're told train B is traveling 72 miles an hour, again for a total of 4 hours. Now we just do the math. 65 times 4. 5 times 4 is 20. Carry your 2. 6 times 4 is 24. 25, 26. So train A traveled 260 miles in 4 hours. Train B traveled 72 times 4. 4 times 2 is 8. 7 times 4 is 28. 288 miles per hour. The difference, of course, would be 288 minus 260, which would be 28 miles. Okay, so sometimes they set up the problem such that you have to actually work out the distance separately. Okay. Mark and Mickey are heading for the same place. Mark is 120 miles away and traveling at an average speed of 50 miles per hour. Mickey is 135 miles away and traveling at an average speed of 45 miles per hour. Who will arrive first? So let's make a little timeline. Again, they're both starting at the same place. They're both leaving at the same time. Well, they're actually starting at different places. Mark is going 120 miles. And he's traveling at 50 miles per hour. Mickey is 135 miles away from the destination. And he's traveling at 45 miles per hour. Okay? So you may be thinking about how to set this problem up, but let's think about it this way. Mark is traveling a shorter distance at a faster rate. Mickey is traveling a longer distance at a slower rate. So right off the bat, we know Mark is going to get there quicker. He's going faster and he has a shorter distance to cover. Okay? Imagine if we had a third person going 100 miles and they were traveling at 100 miles per hour. Same principle. This guy would get there before both of them. Again, shorter distance, faster speed. So in this case, you actually didn't have to do any work to solve the problem logically. Okay, and I believe this is the last problem in the presentation. You may have noticed that as we've gone through problems, they've gotten progressively more difficult. If you see a problem like this will probably be one of the tougher problems you'll see on the arithmetic reasoning section of the Asvab. Okay, so the problem is two bicyclists head toward each other from opposite ends of Main Street, which is 6 miles long. The first biker started at 2:05 going 12 miles per hour. The second biker began pedaling 4 minutes later at a rate of 14 miles per hour. What time will they meet? Okay, so this is, again, two people starting at opposite ends and meeting somewhere in the middle. We're told that they're going a total distance of 6 miles. This one's traveling this way at 12 miles per hour. And this one's traveling this way at 14 miles per hour. Question is, when will they meet, or how long before they meet? The caveat in this problem is this guy who's pedaling at 12 miles per hour actually leaves 4 minutes before this guy. So in other words, we have to figure out how far he travels in those 4 minutes before they both start heading toward each other at the same time. So let's go ahead and do that. distance equals rate. Again, this guy is traveling at 12 miles per hour. And some of you would be tempted to put 4 right in the bracket, but again, 4 minutes, we have to put that over 60. Okay? So this is going to tell us what distance he traveled in those 4 minutes that he got a head start. Let's go ahead and work this out. 12 times 4 is 48 over 60. Okay, and let's go ahead and reduce this. 8 goes into 48. Let's see. Let me work this one out here. 8 goes into, or let's do 4. 4 goes into 48. 12 times. 4 goes into 60. Let's see, 4 goes into 6 once without going over. Subtract the 4 out. You're left with 2, 0. That's 4 goes into 25 times. So this reduces to 12 over 15. 3 goes into 12 4 times. 3 goes into 15 5 times. 4/5 is the decimal 0.8. And I'll work that out in case you don't know how to. 4 divided by 5. 5 can't go into 4, so we add a 0 and bring up a decimal. 5 goes into 48 times. 5 times 40 is, or 5 times 8 is 40. Subtract no remainder. So in 6 minutes, or those 4 minutes that this guy had a head start, he traveled 0.8 miles. Okay, so in light of that, we have to take 0.8 away from this. This becomes 5.2. Okay? So now the problem is, once they both start pedaling, how quickly did they cover 5.2 miles? Okay? So let's go ahead and work that out. And again, we're going to be using a combined rate of 12 and 14 miles per hour. So distance is 5.2. The rate is 12 plus 14 miles per hour, which is 26 miles per hour. The question is, how long did it take them to cover that distance? So we're going to divide both sides by 26. This crosses out. We're left with t equals 5.2 over 26. Okay. Let's go ahead and work that out. 26 does not go into 5. 26 does go into 5.2 or 52. So let's go ahead and work that out. 26 goes into 52 twice. Okay? 2 times 26 is 52. We subtract this out, we get a remainder of 0. So this one took 0.2 of an hour to travel this distance. Okay, so let's go ahead and convert this to a time. We know it took 4 minutes right here to go 0.8, and we know it took 0.2 of an hour to go the remaining distance. 0.2 times 60, of course, is 12 minutes. So in other words, it took a total of 16 minutes from 2:05 for them both to meet in the middle. So 16 plus 2:05 is going to be 2:21. Again, the first biker traveled for 4 minutes, and it took both bikers combined to travel 12 minutes to make up the rest of the distance. Okay, so we just add the 16 minutes combined to 2:05 and we get 2:21. Again, this is one of the hardest problems you'll probably see on the Asvab. As you saw, it required you to calculate distance equals rate times time first. to get the true distance that both of them traveled, and all throughout this problem you had to deal with decimals and fractions. Okay, so on that note, I'm going to go ahead and wrap this video up. If you found it helpful, please feel free to leave some comments in the comment section below or thumbs this video up. Again, if you can handle all the problems in this presentation, you should do very well on these problems during the real test. So on that note, I'll go ahead and cut you loose.
Konnichiwa.